You're welcome to the Scholar School. We establish our footprints on the sand of time, experience the difference.
Hi, welcome to the Scholar online class. My name is Abiola Dali. So today I'll be taking us through mathematics. So we have a topic here, number based in mathematics. And we have a question that seems like kind of not from number based. Now, we have find x and y if 32x plus 51y equals 10 base 10. 32 base x plus 51 base y equals 10 base 10. Then 23 base 10 plus 42 base y equals 7 base 10. Now, one thing we must understand is that every digit numbers we do make use of every day in mathematics, they are to base 10. Though we have other numbers that are more than base 10, but the general numbers we have, the basic numbers we have, they are in base 10. And the ranges from 0 to 9. All those numbers are under base 10. Now, we have this question here equated to base 10, this to base 10. That means to be able to solve this question, we need to convert it to base 10, each of these to base 10. So we are going to have our equation 1 and this as equation 2. So we take equation 1, which is 32 base x plus 51 base y equals 10 base 10. Convert 32 to base 10. So you have your 0, 1, likewise here 0, 1. So we have your 3 times x raised to power 1 plus 2 times x raised to power 0 plus, you also convert this to base 10, 5 times y raised to power 1 plus 1 times y raised to power 0 equivalent to 10 base 10. So here you have 3x plus anything raised to power 0 gives us 1, so we have 2 plus 5y plus 1 equals 10 base 10. Here we already have them to be in base 10. So we have our final answer to be 3x plus 5y plus 2 plus 1 equals 10. Now we have to omit the base 10. So we have 3x plus 5y equals 10 minus 2 minus 1. So we have it to be 3x plus 5y equals 7. This is my real equation 1 now. Now the next thing we also do is to take our equation 2, which is 23 base x plus 42 base y equals 7 base 10. We also do the same thing we did for equation 1, we convert to base 10. So we have 2 times x raised to power 1 plus 3 times x raised to power 0 plus 4 times y raised to power 1 plus 2 times y raised to power 0 equals 7. So here we have our 2x plus 3 plus 4y plus 2 equals 7. So here we have our 2x plus 4y equals 7 minus 3 minus 2. So we have 2x plus 4y to be equivalent to 7 minus 3, that is 4, minus 2, that is 2. As my new equation 2. So I have two simultaneous equations of two unknown. So I can now find my x and my y. So next thing I do is to move down here, write out the two equations. Equation 1 to be 3x plus 5y equals 7 and 2x plus 4y to be 2. So I have this. Now I can either use the elimination method or the substitution method. So I am choosing to use my elimination method. So I want to multiply my equation 1 by 2 and my equation 2 by 3. So I can be able to eliminate my x. So I have my equation 1 to be 6x plus 10y equals 14 and 6x plus 12y equals 6. Now I can eliminate because they are having the same sign, so I subtract them. So I have 10 minus 12y, 10y minus 12y, which is minus 2y equals 14 minus 6, which is 8. which is 8. So I have my y to be equals to minus 4. I have my y already. So the next thing I do is to substitute for the value of y in either of these two equations. These two equations. So I'm choosing equation 2. So I substitute minus 4 for y in equation 2. So I have my equation 2 to be 2x plus 4y equals 2. So I have my 2x plus 4. My y is minus 4. Then I equate it to 2. So that I will have my 2x minus 16 to be equals to 2. Then I have my 2x to be equals to 2 plus 16. Then after that, I had the other side, I have 2x equals 18. I divide both sides by 2. Then I have my x to be equals is equivalent to 9. So therefore, my x is equals 9 and my y is equals minus 4. So these are the two values requested in the question, and that's how to solve this. Now, I would like us to take another example of a number-based question that can lead us to simultaneous equation. Now, we have this question here. This is my equation 1 and this is my equation 2. So I have to find my real equation 1 and my real equation 2. Now, this case here is kind of different because our first question we have them in base 10. But this here we have our question here in base 2. It's equivalent to base 2. So we need to convert them to base 10. So we follow the same pattern. So I start from the first one. 1 times x is power 2 plus 0 times x is power 1 plus 1 times x is power 0 minus y equals 1 times 2 base 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. So here I have my s square. This gives us 0 plus 1 minus y equals this is 2 plus the 2 square will give us 4 rather plus 2 plus 1. So I have s square plus 1 minus y equals this gives me 7. So I have s square minus y equals 7 minus 1, which is s square minus y equals 6. My equation 1. So the next thing I also do the same thing for equation 2. I have my 1 times x is power 1 plus 1 times x is power 0 plus 1 times y is power 1 plus 0 times y is power 0 equals 1 times 2 is power 2 plus 1 times 2 is power 1 plus 1 times 2 is power 0. So I have here to be x plus 1 plus y plus 0 equals I have my 4, I have my 2 and my 1. So I have here x plus y to be equivalent to 2, 4 plus 2 plus 1 minus 1. So I have x plus y to be 4 plus 2, which is 6. 1 minus 1, that is 0. So I have my equation 2. So I have two equations. And now here it is not just a simultaneous equation, but rather simultaneous linear and quadratic equation. So we cannot proceed in solving this question. I have two equations. So I'm taking equation 2. The first thing I will do here is to make my y the subject of formula. So when I make y, I have my y to be 6 minus x. So I call it my equation 3. So I will now substitute for my next equation, which is my equation 1. So I have my equation 1 already to be x squared minus y equals 6. So I'm substituting for y. So I have my x squared minus 6 minus x to be equals 6. So I have my x squared minus 6 plus x to be equivalent to 6. So I simplify it, so I have my x squared plus x minus 6 to be equivalent to 0. So I have x squared plus x minus 12 equals 0. And this is a quadratic equation. And to solve a quadratic equation like this, you take your constant c, which is minus 12. Two numbers that when you multiply them together, they give you minus 12. And we add them together, they give you plus 1. So you have your 4 and 3. That is 4 and minus 3. 4 times minus 3 will give us minus 12. And 4 minus 3 will give us 1 as the coefficient of x. So I substitute the values. I have x squared plus 4x minus 3x minus 12. So that this equation can be reversible. Because 4x minus 3x will still give me what? My plus x. So I fish out the common factors here. So I have my x plus 4 and minus 3x plus 4 equals 0. So I pick out the one that is common. I have my x plus 4, then x minus 3 to be equivalent to 7. So plus 4 will be equated to 0, or my x minus 3 equated to 0. So that my x here will be minus 4, or my x here will be 3. So I have two values of x. So the next thing I'll do is to know that the base of any number can never be a negative sign. When it comes to number base, we don't have the base of any number to be a negative integer. So we scrap this out, and this will never be our answer. So we choose our x when it is 3. So we now substitute into equation my equation 3, so as to find my y. Since my y equals 6 minus x, so I have my y to be 6 minus 3, which is 3. So therefore my x equals 3, or my y equals 3. So the base of each of these, that means 1 is in base 3, and my y is 3. Then 1 is there in base 2. Then the other one, 11, that is 1 base 3 plus 10 in base 3 is equals 1 base 2. So this is how to solve question under number base that leads to simultaneous equation and likewise simultaneous linear and quadratic equation. So thanks for watching, and make sure you like, subscribe and share to your friends in order to watch more educative videos on mathematics. Once again, my name is Abiola Daniel. Thanks.